Okay, again.
Okay, good morning everyone. Good morning my dear M6. Welcome to our mathematics online class. Yes, so it's been a while we didn't meet. Alright, so I'm sorry to mess up with your schedule because last meeting I went to the immigration to fix my visa and so I wasn't able to meet you guys. So today we'll be having two sessions. So I'm meeting you now and then we will meet again in the afternoon. So I heard that you'll be having many maths today. Okay, so let's take it easy with our mathematics then. Alright? So our lesson for today is all about maxima and minima. And we will continue this topic in the afternoon, of course, for the application. So we will apply our lesson on maxima and minima in our session in the afternoon. Okay? So again, welcome everyone. Welcome to our mathematics online class. Alright, so let's get started. Okay, so first, I would like to tell you how am I going to give you your scores, of course. So you will be, I will give points for your attendance. Okay, so you will get points for your attendance as well as, of course, for your participation. So I encourage everyone to please participate, get your paper and pen, and let's solve together. Because mathematics is all about solving, right? So grab your paper and pen, let's solve together. And you will get points for your participation as well as for your attendance, of course. Okay, so first, we have here our motto. Okay, I made a motto for you for this COVID online class. We have here, COVID can't stop us from learning our math. Okay. COVID cannot stop us from learning our math. So let's go on. Alright. First, of course, we will discuss or we will deal with our vocabulary. Yes, because we need to define some words or some terms. So I will ask you now your participation. Okay, so if you know the word being defined by our vocabulary, then please write your answers on the comment. Okay, so here is our first vocabulary. Alright, it is an expression representing the rate of change of a function with respect to an independent variable. So what do you think is the word being defined here? You don't have idea? Okay, so I'll give you some choices. Is it reciprocal? Is it derivative, tangent, or normal? Okay, so go on and choose your answer from the choices for our first vocabulary. Who will get the first plus points? Okay, so our vocabulary here, it is an expression representing the rate of change of a function with respect to an independent variable. So is it reciprocal, derivative, tangent, or normal? What do you think is the correct answer? Okay, welcome. 6/3, number 20. 6/6, number 6. Welcome to our class. We have also 6/5, yes. A representative from 6/6. I can see here 6/7. Yeah, so what is your answer with our first vocabulary? What do you think is the word being defined here? Okay, go on and type your answers. 6/8, number 11. Welcome. 6/8, number 6. Okay, we have a representative of 6/8. Alright, I can see no answer here. Go on. So what about the rest? Okay, so if your answer is derivative, then you are correct. Okay, so our first word here is derivative, and it is an expression representing the rate of change of a function with respect to an independent variable. Yes, that's correct. Okay, very good. All right, let's now move on to our next vocabulary. What about this one? Okay, is a line that touches the curve at one point. So it is a line that touches the curve at one point. Can you guess? Do you know the word being defined here? Okay, if you don't have idea, then here are your choices. Is it slope, function, tangent, or normal? So remember that normal here is not the normal, new normal. No, it is the normal line. Of course, we have tangent line, we have normal line, right? We discussed that in our previous lesson before. And then we have slope, of course, and function. So what do you think is a line that touches the curve at only one point? So the answer is it function, slope, tangent, or normal line? Okay, so I can see here already correct answer. So if your answer is tangent, then you are correct. Very good. Okay, very good. Yes, that's correct. All right, here's our next vocabulary. If you didn't get the first two, then you still have chance. Here is the third vocabulary. Is a line perpendicular to a tangent to the curve. So it's another line, but this time it is perpendicular. Is it slope? Is it intervals, tangent, or normal? So what do you think? Is a line perpendicular to a tangent to the curve? Yes? Okay, so you have here your choices. This is our third vocabulary. So it's again a line perpendicular this time. It is perpendicular to a tangent to the curve. Okay, so I can see already correct answers. So if your answer is normal, then you are correct. So we're pertaining here to normal line, right? It's not the normal, new normal. It's the normal line. So this is the line that is perpendicular. When I say perpendicular, of course, then you must form a 90-degree angle, right? For you to have a perpendicular line. Okay, all right, very good. Those answered normal, you're correct. Okay, next vocabulary. What about the y value? Okay, so we have here another situation. The y value decreases as the x value increases. So what do you think? If the y value decreases as the x value increases. Sorry, okay? So is it strictly increasing function, decreasing function, or slope? What do you think is being described with this statement? The y value decreases as the x value increases. Okay? So remember the difference between strictly increasing and simply increasing, right? When we say strictly increasing, we don't allow flatness. But when we say increasing, then it's okay to have some flat part of our curve, right, of our function. But when we say strictly increasing, we will not allow flatness. So what do you think is the word being described here? Okay, I can see some answers, correct answers here, right? So the y value decreases, the x value increases. All right, so if your answer is decreasing function, then you are correct, okay? Decreasing function is correct. All right, let's move on. Okay, I think this is the last one. So we have here a point on the curve where the gradient is 0. You know what is a gradient, right? Gradient is another term for slope, of course. So is it a slope? Is it strictly increasing, critical point, or tangent point? So a point on the curve where the gradient is 0. So what is it? A point on a curve where the gradient is 0. Is it strictly increasing? Slope, critical point, tangent point. Alright? Okay? Alright. So I can see correct answers now. Very good. So if your answer is critical point, of course you are correct. So critical point where the gradient or the slope is 0, because that is our turning point, right? That is the point wherein our function will either increase or decrease. So if your slope is 0, then you have your critical point. Okay, very good. Alright, so let's now move on with our lesson. That's all about our vocabulary. So there are 5 in total. Yes, that's correct. Critical point. Yes. Okay, so let's now move on. We have here our graph or our illustration for local maximum and local minimum points. Yes, so how do you know whether the point is maximum or minimum? Of course, we know the meaning of maximum, right? Maximum are the highest and minimum are the lowest. So you must identify your maximum if you have a concave. This is max. We're going to consider it as a maximum point if it is on the top of your concave part of your function, yes? But if it is convex, like this, then this will be our minimum point, right? So the difference between our max and min. Now we have here local max and global max. What's the difference between local max and global max? So local max are what? All the maximum points can be considered as your local maximum, but the highest among these maximum points will be considered as our global maximum point. Okay? And same is true with our minimum, of course. Yes? So minimum are the point that you can locate on the convex part of our function. And all these minimum points can be considered as local minimum. Now the lowest among these minimum points will be our global minimum. Okay, so let's dig it deeper. So we have here another illustration. So the local maximum point of a function is defined as that point whose y value is the greatest. Yes, of all the y values of the point in a small neighborhood. So by the word local, local means it's only inside, right? It's just a small neighborhood. But when say global, that is worldwide. Yes, worldwide. All right. So just take this concept so that you will understand about the meaning of local and global. Yes. So we have here point P is our local maximum. Of course, you can see there. You can locate in our illustration that point P there is our local maximum point. And the other term for local maximum is relative. Yes. So relative maximum is another term for our local maximum. If you encounter the word local, that is the same as the word relative maximum. Okay, so local maximum and relative maximum are pertaining to the same thing. All right. Now, what about our local minimum? Of course, it's just the opposite of our local max. So that is a function, or a function is defined as the point whose y value is the least of all the y values of the point in a small neighborhood of the point. So again, it's a small, we have here the word small neighborhood because of the word local, right? And the other term, of course, okay. So we have here point Q. Where's point Q? Over here, right here. So point Q is our local minimum, right? And the other term again for local is relative minimum. Okay. Let's move on. All right. We use the term local minimum point or local maximum point because outside the intervals considered, they may be other points whose values are greater than the y value of the local maximum point. So what does it mean? A local minimum or local maximum can be what? Can be more than one, right? Can be there can be other local minimum and maximum point outside our interval. So that's why we call it local. Okay? And so a function can have more than one. So that's what my point a while ago. A function can have more than one local maximum or minimum point on its domain. Yes. All right. What about global maximum? So here we go with our global of a function. Is the point which has the greatest, right? So from the beginning, I already give you this concept. Greatest y value in the domain. Yeah, so we call that global. Similarly, global minimum point is the point where the function attains its least, okay, least y value. All right. Yeah, these values are also referred to as absolute. So another term for global is absolute. Another term for local is what? Relative, right? Local, relative, they're the same. Global, absolute, they are also the same. Okay. So we have here the word extremum is used to refer to either a maximum or minimum. So if you use the word extremum, it is pertaining to at least what? Maximum or minimum. It's not at the middle, no, but it is on the max or on the mean. Okay. So the plural of the words maximum is maxima and minima, respectively. Yes. So you can use the word maxima and minima if you're pertaining to more than one maximum or minimum points. All right. What about inflection? So we have another vocabulary here. Inflection is a change of curvature from convex. So we already discussed it a while ago. Convex to concave at a particular point on a curve. Okay. So convex, it's not the same as your definition in your science. Convex here will be pertaining to like this. And concave will be, looks like a cave. That's why we call it concave. Okay, particular point on a curve, right? So actually our lesson for today is to find the relative max or the relative mean of a function using derivatives, because our lesson is actually derivatives, right? So how are we going to do that? First, we're going to find the derivative of the function that will describe the slope of the tangent line. Yeah? And then, after that, when the tangent line has a slope of 0, what will happen? The line is horizontal and basically located at turning points on the graph line. Yeah? So we have our horizontal, and so that is the turning point of our function. It's either it goes up or it goes down. Okay, so horizontal line is located at the relative max or relative mean. That's why we need to we must know what is our relative mean and relative max, because in that point we will find our horizontal line. Okay. All right, so we have here our first example. So please get your paper and pen. Let's now going to solve. Okay, it's time for us to solve. So the first one here is we're going to find the relative extrema. Extrema means what? We're going to find minimum and maximum, okay, of our function 2x cubed plus 4x squared plus 3. Okay, so we have here, we're going to write it, f of x is equal to 2x cubed plus 4x squared plus 3. So what is our first step here? Step number 1. We were going to find the derivative. So I'm going to ask you now. It's time for you to participate. I believe everybody knows how to do their derivative. So what is the derivative of our function? Go on and type on the go on and type your answers. What is the derivative of 2x cubed plus 4x squared plus 3? 1. Okay, I can see here already answers. Yes. Okay. Any other answer? Alright, yeah, you can use the caret like this for your exponent. Yes, because it's difficult to type exponent there. So you can use caret to designate your exponent. Yes, that's correct. Okay, very good. So if your answer is, the derivative of the function is 6x squared plus 8x. Okay, so no more constant because the derivative of the constant is of course 0, right? So we have the derivative of the function. This is the first step. And so let's proceed to the second step. Step number 2 is solve for the roots. So how are we going to solve for the roots? We have to what? We need to equate it first to 0, right? Because we already know that if the slope is 0, then we can get our critical points. Yes? And so to solve for the roots, remember when I say solve for the roots, we're going to solve for the values of our variable. Our variable here is x. So what are the values of x? Okay, so equate it first to 0, then solve for x. Okay, go on and type your answer. What would be the value of our x? Since we have here a quadratic function, so you'll be getting 2 values of your x, right? So what would be the values of your x? Okay, x equals what? Go on, type your answers. What are the values of x in this particular situation? Okay, yeah, I guess the correct answer. What about the rest? Go on and type your answers. Remember, you can get plus points for your participation. Yeah. Okay, so if your answer is 0 and -4/3, then you are correct. So the value of our x here is, or r 0 and -4/3. There are 2 values because we have a quadratic function, right? You're correct. Very good. Okay, so that is step number 2. Step number 2 is find the roots, right? Solve for the roots. Step number 3 is we're going to substitute the value of x we got in our function itself. Okay, what is our function? Of course, we have here f of x is equal to 2x cubed plus 4x squared plus 3. So go on and substitute the value of our roots or of our x to our function and give me what you got. So if x is equal to 0, what would be the function of x? Okay, very good. If x equal to 0, we have that already. What else? Who else can give me an answer? Yeah, so you have to write if x equals 0, what would be the value of your y? Y or f of x, right? Function of x. What would be your function of x? Okay? Yes, okay, so if x is 0, of course it's very easy. The answer is 3, right? Because everything will be turned to 0 except our constant 3, because 3 doesn't have any variable x. Okay, next, what about if x is equal to -4/3 or 4/3? Okay, what would be the value of our f of x in that case? Yeah. Okay, go on and solve. This time it's a fraction, so I give you a little bit time to calculate your fraction. What would be the value of y, or what would be the value of the function of x if x is equal to -4/3? Okay? Okay? Grab your paper and pen, try to solve for you to get some points and participate in our online class. Yeah, okay, so somebody already put an answer here. What about the rest? Come on. Try it, try it, try it. Alright. Okay. So it's time to reveal the answer. F of -4/3 is equal to 145 over 27. Very good. Okay, very good. You get it correctly. All right. Or we can write it as 5.30 or 5.37. Okay, so that we can compare. Because the next thing, our next step is to compare. We're going to compare because remember that we're finding the maximum and the minimum. So it's time to compare. Which one is greater and which one is smaller? Okay, so we can see here that if we're going to compare 3 and 5.37, of course this will serve as our max because it is greater, and this serve as our mean because it is smaller. So after comparing them, you can now write your conclusion. Relative mean is what? 3 at x equals 0. Now you can write this as an ordered pair, 0 and 3. Okay, x is 0, y is 3. Our function of x is 3. Okay, this is our relative mean, and our relative max, of course, is the other one, which is 5.37 at x equals negative 43. So you can write it again as negative 4 over 3, comma 5.37. Or you can use also the fraction form. Okay, so I can accept fraction or decimal. If you prefer to write decimal, that is fine. Fraction is also fine. Okay, so we already identify our relative mean and max in our function 2x cubed plus 4x squared plus 3. Now let's try to see that the graph, if our answer is really correct. So let's see the graph. Where's the graph? Okay, this is our graph. You can see here that what? We have here 2 points. That is our concave and this is our convex. So obviously this is our max, right? Max. And if we want to read our max, our x is what? Our x is around negative, is it? Alright, so our x is there. So negative 4 over 3, around here, right? It's negative, it's correct. And our y is 5.37, around there. So it's fine, it's correct. Now what about our mean? Our minimum there is at 0, 3. So it's correct, right? Our x is 0. And our y is 3. So you can see here that we found our minimum and maximum by using our derivative, our lesson on maximum and minimum for derivatives. Okay, so let's go back to the step. What is the step number 1? Step number 1, you have to find the derivative. Yes, step number 1. This is step number 1. Step number 2, solve for the roots. Yes. After solving for the roots, step number 3, you're going to substitute in our function. And then step number 4, you're going to compare to find out which one is minimum and which one is maximum. And that's it. Okay, let's have another example here. Okay, grab your paper and pen. This is for you. Alright, so our function here is x squared minus 2x plus 1. Okay. So step number 1, we're going to find the derivatives. Okay, go on and write the derivative of our function. What is the derivative of x squared minus 2x plus 1? Okay. Alright, it's time to get some points. Guys, come on. Type your answer. Derivative. What is the derivative of? Yes. Okay, very good. So again, use the caret symbol for your exponent. Okay, if you need an exponent, you can use the caret symbol. But in here, okay, the exponent will be gone. Yes, of course. All right. So very good. Those who answered 2x minus 2, you are correct because the derivative of our function, of course, is 2x minus 2. It's a simple derivative. I'm giving you simple example, but of course you can dig it further with your application of what? Of your chain rule, what else? Product rule, quotient rule, and the other rules. Right? But this one are just simple derivatives, just for you to keep on, just for you to follow the steps. Okay? Alright, so we're done with the derivatives. Step number 2 is what? we're going to solve for the roots. Yes? So go on and find the roots. Solve for the roots. What would be the value of x here? It's again an easy question to everyone. What would be the value of x? Okay. So first, of course, you have to equate it to 0, right? For you to get x. X is equal to what? Go on. Yeah, okay. Very good. Alright. Okay, so I think it's not a very difficult question, and so let's now reveal the answer. Yes, that's correct. So x is equal to 1. Very easy, right? X is equal to 1. So after finding the roots, step number 3, we're going to what? Substitute. It's time to substitute with our function. If x is equal to 1, what would be the value of y? Or what would be function of x? If x is equal to 1, go on, solve. What would be the value of y if x is equal to 1? Okay, let's wait for a while. Yeah, we're done with the value of x. Now, we're now finding the value of y. So, what is f of x if x is equal to 1? Yeah, okay. Alright, so let's see. If x is equal to 1, then we have 0, of course, right? Now, the next step is we're going to compare, right? But how can we compare if we have only one value of x? So it's difficult for us to compare, right? How can you if we compare, we need at least more than one value of x. But in this case, we have only one value for x. And so, it is not possible for us to compare. And so, we need to get our second derivative because we cannot compare. Yes? So, use second derivative. What would be the second derivative of our function? Remember that this is our first derivative here. So, go on and get the second derivative. That would be f prime of x. What would be? Okay, come on, type in your answer. The second derivative, of course, is very good. Yes, that's correct. It's 2. Okay, so our second derivative is 2. Now what we're going to do? Yeah, that's correct. So after you find the second derivative of the numbers, if greater than 0, the second derivative is greater than 0, meaning it is positive, right? If the derivative is positive, it is minimum. So you can see here that they're opposite, right? Greater than 0, minimum. If it is equal to 0, what will happen? It is either max or neither. Now, either max or mean, neither max or mean. Because we cannot of course, decide if it is 0, right? Because 0 is a critical point, okay? So, just consider greater, positive and negative, okay? If it is 0, we cannot do anything. So, if it is positive, it is minimum. But if it is less than 0, meaning it is negative, it is max, so it's the opposite, right? Why is it opposite? Because this is already our second derivative. So for the second derivative, we're going to use the opposite. If it is greater than 0, it is mean. But if it is less than 0, it is max. Okay, so let's proceed to our answer here. Our second derivative is 2. Obviously, it is greater than 0, right? It is positive. And so therefore, we will consider our answer to be minimum, of course. So you can now write your conclusion. Therefore, the relative minimum is 0 at x equals 1. Again, you can write it as an ordered pair, 1, 0. This is our relative mean. Okay? So if we're going back to our example showed that what? If we arrive with only one value of x and we cannot compare, then we need to use our second derivative for us to identify whether the value we got is a maximum or minimum. So in conclusion, second derivative will help us to identify whether our point is what? Maximum or minimum. Now remember, if the second derivative is greater than 0, it is minimum. But if the second derivative is less than 0, it is maximum. Of course, if it is 0, then we have no point of what? Of interaction. Or I mean, if it is 0, then we cannot decide, right? It's either or neither, max or min. Okay, right? So let's see. Do I still have? All right. So this is the graph of our given example number 2. You can see here that our graph showed that it's really on its minimum, the relative minimum. The point is on at the minimum point of our function. So relative mean at x is 1 and y is 0. Okay, so that's how we're going to get the relative mean and max. Okay, all right, so it's your turn. We have here one more example. We still have 15 minutes, I think, so we can still discuss the one. All right, so your turn. Find the relative extrema. Relative extrema means what? Again, it's the minimum and the maximum, right? Okay, so step number 1. Go on and give me step number 1. Step number 1. What would be our step number 1? Hello? Okay, tell me. First, tell me what is the first step. Let's see if you can identify the first step. Step number 1, guys, what is it? Oh, you already give the answer. So step number 1, of course, is what? Find the... Nobody. You already answered it. But, okay, I can see now. Alright, step number 1 is find the derivative. Yes, find the derivative. And somebody already find the derivative. Soitong, yes. So the derivative is what? So we have your fraction. Of course, you know how to deal with your fraction, right? Fractions are just fractions. Okay. So we need to find the derivatives. Go on and find the derivatives. I can see correct answer here. Very good. So the derivative will be 5x to the 4th. Yes, minus 5x squared. That's correct. Okay. So again, the constant one will be what? Gone, because it is the derivative of a constant is 0. Okay. So after finding the derivative, what's step number 2? Tell me first the step, okay? Before you find the answer, you tell me first what is the step. Step number 1, find the derivative. Yes, that's correct. Very good. What is step number 2? All right. You're very active, Soitong. 6/4, number 14. Very active in answering. Yeah, okay. I appreciate your participation. Alright, so solve for the root. Yes, so find the root. How to find the root? You have to what? Equate it to 0. So go on and solve for the value of x. What would be the value of x here? If 5x to the 4th minus 5x squared equals 0, what would be the value of our x? Values, right? It's again a quadratic, so I'll be getting 2 values of x. Solve for root. Yeah, that's correct. Now it's time for you to solve for the root. Step number 2 is solve for the root. Go on and solve for the values of x. What would be the value of x? Yes? Alright. I can see now. Okay, so I guess some of you are solving. Bodenchai already have his answer. Yeah. Okay, what about the rest? Come on, show me your answer. Show me what you got on your paper and pen. Okay. Yes, that's it. Okay, correct. So the value of x, there are 3 values of x actually. We have 0, positive, and negative 1. Yeah, you have to consider positive and negative 1 if you get a square root, right? Remember the square root will give us two answers, of course. We have the positive and the negative root. Yes, that's correct. All right, after finding the roots, what would be the next step? So we're already on the 3rd step, right? Step number 1, find the derivatives. Step number 2, solve for the roots. What would be the next step? Tell me first the next step before you give your answer. Step number 3. What is our step number 3? Yes. Right. Very good. So substitute. Okay, just write it there. Substitute. So substitute in f of x, that's correct. Very good. So substitute in our function of x. Okay, that's our third step. So go on now and substitute. What would be? What do you get? First, okay, let's have if x is 0. If x equals 0, what would be f of x? Okay, all right, so you can answer any of these values of x then, but you have to write if x is equal to 1 in your answer so that I know what you are answering. Okay, if x is equal to -1, what would be f of x? Right? Okay, so if you write your answer, be sure to write if x equals 0, then I will know what you're answering, because there are 3 questions here, right? There are 3 questions. So you can also write like this: f of 0 equals, it means you substituted 0, right? Equals what? You can also write f of 1 equals what? Or f of -1 equals what? Okay, you can answer like that. Go on. Yes, I can see that already answers. Somebody answered if x is equal to 1. What about if x is equal to 0? If x is equal to 0 is the easiest one, right? Because if you substitute 0, everything will be 0 except for the constant, of course. Yes, that's correct. So be sure to write. Somebody answered if x equal to 1. Okay? Yeah? Alright. Oh, you answered everything. CNY vlog. CNY vlog. Okay. You are 6/4 number 12. You give everything. Yeah, that's correct. Very good. Appreciate your participation. Write all of the answers. Yes. What about the rest? Just go on and write your answer. Okay? Alright? Yeah, that's correct. Okay. So let's reveal now our answers. So if x is equal to 0, of course it is 1. That's the easiest one. Everything will turn to 0 except the constant. Yes. What about if x is equal to -1? We arrive here with -1/3, or that is approximately -0.33. So if you can compare fractions, sometimes it's easier to compare decimals, right? So it's good to write your answer in decimals. It's easier to compare than fraction, of course. But if you are that good in comparing fraction, then no problem, right? Go on. Next, what about if x is equal to 1? So we arrive here, -5/3. So you're correct, very good. -5/3, or that is approximately -1.67. Now what is our next step after identifying the values of the function by the roots of our equation? What will be the next step? Step number 2 will be what? Okay, let's clear out our board first because it's already messy. Okay. Alright. So find the derivatives again. Solve for the roots. Yes. Substitute. We're already done substituting. Hey, what would be the next step? Tell me the next step. Alright. Very good. So we're going to compare, right? So compare. So which one is the highest here? Is it -1, -0.33, -1.67? Okay, tell me, what do you think is the maximum? Very easy, right? So tell me now the maximum and the minimum. Compare, yeah, that's correct. Compare, yes. So try to compare now. Which one is max? Which one is mean? Yes, correct. Yes. So which one is max? Which one is mean? Obviously, our max is what? Yes. Okay. So try to compare now, guys. Yes. The next step is compare. Yeah, we'll compare. So try to compare now. What would be our maximum and what would be our minimum? Relative max, relative mean. So this is now our final answer. Okay, F1. Yeah, okay, that's correct. Very good. Very good. Okay, of course, obviously, when we are when we are talking about negative numbers, the least is the max, right? Because the closer to zero, if it is negative, the closer to zero, it has the higher its value, right? The closer to zero, the higher its value when it is negative. So obviously we have here negative 0.33 is our max. What about our mean? The farther to zero will be the lesser the value when we are pertaining to negative, right? So we have here our mean. Yes, very good. After identifying your max and mean, then go on and write your answer. So relative mean is what we have. So you can write it as an ordered pair this time, yeah? So we have x is 1 and the value of y is negative 5/3. Yeah, that's correct. Yes, and of course our relative max is at negative 1 and negative 1/3. Yes. Okay. Correct. Correct. Very good. So before we end up our lesson, because I think this is the last example here, so let's try again to what? To summarize our lesson. Yes. So our lesson is finding maximum, relative maximum, and relative minimum. Alright, we're going to apply this lesson in the afternoon, because in the afternoon we'll be going to solve problems, problem solving, word problems, and we will apply this lesson. So be sure to remember all the steps. Okay, so step number 1, we need to find the derivatives. Of course, you know how to find your derivatives, right? You have to apply your chain rule if it is necessary, your quotient rule, your product rule, and other rules if it is necessary. Okay, so the first step is find the derivatives. Step number 2 is, of course, you're going to what? Solve for the roots. So before you can solve for the roots, you have to equate it to 0. Yes? After finding the roots, the next step is substitution. We're going to substitute the value you got in our function. And then finally, you have to what? Compare. Yeah, you're correct. You're still answering. So compare. Why we need to compare? For us to find out whether it is maximum or minimum, right? Of course, max is the higher one and min is the lowest. Yeah. Okay. Now, what about if you arrive with only one value of x? So there's no way to compare, right? If it is not possible for you to compare, then it's time for you to get the second derivative. Yes. So find the second derivative, and whatever you got, if the second derivative is positive, then it is minimum, right? It's the opposite. If the second derivative is negative, it's less than 0, and so it is the maximum. Okay? What about if the second derivative is 0? Then we cannot decide. It's either or neither, max or min. Okay? Alright? So that's all for today. See you again. See you again in the afternoon. Okay? Please tune in with me in the afternoon. We're going to solve problem solving. We're going to do problem solving in the afternoon, and we're going to apply our lesson for today. And I want you also to prepare A4 paper in the afternoon. I'm going to show you some activity, a little activity, on how we're going to deal with our problem solving in the afternoon. Okay? Alright, keep safe everyone. Thank you for your participation. See you again or meet you again in the afternoon. Okay, bye.